Hello. Buenos días. Good morning, everybody. So today we have our friend Luca from Eiger, who's going to talk about the Zcash UniFFI library. So welcome, Luca. And all right, I'll leave you to it.
Thanks. So, hi, I'm Luca. I work at Eiger, and I'm here to talk about the Zcash UniFFI library. This project was financed on behalf of the community by the Zcash Grant Committee. And prior to working at Eiger, I mainly did backend development with functional languages. And once at Eiger, I had the opportunity to do more blockchain development and research, and I'm very happy and thankful for that. I want to showcase our work and advertise it and increase its visibility a bit among the community. I'm delighted to be here in Barcelona with you all, as we talked and we interacted. It was really nice. And I'm eager to answer any question you might have in this presentation or afterwards in the corridors, so on. So I have a question for you all. I assume most of us are programmers or no programming ethos. We know that the benefits of learning different languages. Each language teaches us new techniques, new ways of thinking, and different approaches to a problem. But what about the benefits of having libraries available in one language? For example, Node was revolutionary because it let programmers with a deep knowledge of JavaScript with backend applications, write backend applications. Before Node, this was impossible, and this resulted in a lot of programmers being cut out of this particular domain. Sharing knowledge and collaborate on various technologies is, of course, how we innovate them. And I want to share how this is possible using one language that you may already know in place of learning a new one, Rust. So first I wanted to present Eiger, my company. It's called after the Eiger mountain. In fact, the logo is kind of a mountain. The Eiger is one of the 3 mountains in a permanent glacier in Switzerland. Very beautiful sceneries, been there. So Eiger helps leading blockchain technologies to scale, and it does so by helping with the development of their core technologies. And a part of it is providing a dedicated team of experts in pretty much all areas of Web3 development. So first, some overview. In this, I will first start with the introduction, a bit what is UniFi, what is Libra Zcash, a bit about the implementation, how did we do with the code itself, and some tooling. So because the RFP didn't include only code, but it has also, we also had some bunch of automatizations done in the meantime. Introduction. In this segment, also 3 parts. Who worked on the library? Were the people involved? What is UniFi precisely? And what is Libra Zcash? So some of you still don't know, so it's good for the following to introduce it. So this is the team that did the whole work. This is screenshot directly from GitHub, as many of you can recognize the interface. It's Eloy, Daniel, Łukasz. They are the programmers, and I was part of the team too, of course, but I helped mostly with planning, the development, sharing knowledge about Zcash, as I was the main author of the grant proposal that went to Zcash, to the ZCG. So, the relevant tools for us in Zcash are Zcash D, the first node implementation built by the ECC, mainly by the ECC, and which was written in C++, C, and other languages. Zebra, the Zcash Foundation response to Zcash, their node implementation, which you may have heard of in the previous presentations. But meanwhile, they're represented by the heart, because we love it. The ECC was busy building a library a bit more modularized in a more modern language called Rust. And it's a collection of, it's not one library, it's actually a collection of libraries called crates in Rust. And they are all doing something for building various stuff for Zcash, for the blockchain. The most important example is, for example, a wallet. So so what's the issue then with Libra's Zcash? So what are we building? What's the problem we are solving? Well, if you wanted to build a wallet or a light client, you would need to use Libra's Zcash crate, one of them, or many of them, which implements some common parts like address encoding and key handling. But what if you know another language and wanted to build something for Zcash? You would need to know Rust, and so learn a new language, do some system programming, which is memory management, which is not something you do overnight. So this is the problem we set out to solve in our grant proposal, to make it possible to build on Zcash for a wider array of developers. So, presenting Mozilla, this is the next component of our work. And to describe it in its creator words, UniFFI is a tool that automatically generates foreign language bindings targeting Rust libraries, which I think is the best sentence that summarizes it. It is a library being built and maintained by the Mozilla Foundation, and it is constantly changing, and it's still under heavy development, so it is also relatively young. It is so wonderfully crafted, though, that it adapts to other projects completely unrelated to Mozilla. In very, very simple words, it takes a Rust library, it takes a Rust code base. We write a set of specification with that, which I will present. And then you will find generated libraries in other languages. Which are these languages? So why UniFFI? Because there are other tools, actually, which are similar. So you may then ask, aren't other tools out there that do the same thing? So the whole point of our work was to improve the accessibility of the ecosystem, translating the Rust libraries into libraries for 4 other languages, Ruby, Python, Kotlin, and Swift. The maintenance effort is considerably contained, but we assume this drawback because it is outweighed by all the benefits that it takes. So the specification is written in UDL, which has a lot of in-place conventions, and it really constrains the development, so it's kind of easier to follow with it, to build with it, actually. There is an expert team behind it, Mozilla, so we know that it will be also in the future maintained, and we can be sure that there will be still a tool like in 3 or 4 years. And another good plus is that there are already 4 bindings included in the library, plus 2 other languages, which at the moment, to my knowledge, are the only other 2 backends. They are built by NordVPN, and they have built C# and Go binding. So you can write a Rust library and have 6 libraries generated out of that code. There are some other competitor tools like what is called Interoctopus and Diplomat, but UniFFI is the one that is most developed, and it has a lot of benefits compared to them. So, some details of the implementation. We strive to motivate all of our choices and document all of them in writing. You may find a lot of discussions on our past GitHub issues, correlated with a lot of documentation. And if you dig in our issues, you will find a lot of details on the development process, all the discussions, all the decisions we made it all public. We managed to complete all the features which we could possibly implement, and plus some side tooling which helped automate several tasks, and which is in the third segment mostly. So features, what did we implement actually in concretely? We had to choose what to implement at this stage because Libra Zcash was already quite big and we couldn't possibly do everything. So we decided to fit the most important parts from a functional point of view. So we decided to put inline documentation so that you write it once in the Rust library, and then you will have it exported to all other libraries in their own documentation template. So then you can, for example, automatically generate the documentation in each language ecosystem. There are Docker and Nix images so that you don't have to install a lot of stuff just to develop, but just build Docker and go forward with the development. So from the point of view of the code base, keys handling. So you can generate private keys, you can generate secrets keys, you can derive from there. There is the HD derivation, and there is also support for unified addresses. You can parse, validate, and derive addresses. So you can do a lot of handling with that at the moment. And there is transaction management, which was the hardest part, which lets you build, sign, and validate transactions. Also, there is a lot of tutorials which were complete with like use cases. There are like single-line snippets. They are very detailed, and we tried not to leave anything to imagination or not leave anything to imagination and to case. So everything should be very, very straightforward once reading tutorials. So one of the points we were really focused on was the equivalence between languages. So this was a point that was, of course, very, very, very important. So how do you know that the Rust code will give us the same values that the other libraries give us? Because this was completely unknown. Like, of course, you can trust compilers to do the right job, but you really have to test that, and you really need to be sure that the libraries, for example, generate the same addresses, which I think is quite important. In an effort to avoid such a situation, we created a system to ensure that every single byte generated by the foreign interfaces is in the right place. So doing the testing, there is a routine, a subroutine that starts before testing, which is all the Rust code that are tested in Kotlin, Ruby, and so on are run, and the results are saved on a key value store. And on the foreign binding test side, when they have to take fixtures to assert equivalence, they take these byte-encoded values from the key value store, ensuring that everything is locked in and every single byte is in the right place. So how does UniFFI work and how UDL language works? So as you can see, the languages are relatively similar in, so you can understand what's going on here. The tool will not try, in fact, to export the Rust code directly, because it's not like you have the whole library, you just execute something on a terminal, bam, you have 4 libraries. You have to write a specification file in UDL, which actually tells the compiler and tells us also after what did we export precisely and what are the types used. And basically, UDL is standardizing all the foreign language libraries. So UDL stands for UniFFI definition language, and it is a direct derivative from WebIDL, which has been used by Mozilla for quite some time, like a lot of time. In fact, I think they use it in Firefox, for example, to define APIs, several APIs like WebGL and JavaScript and all the other libraries used in JavaScript, for example. And there are several limitations, though. For example, every single, a repository is always corresponding to a namespace, so you have to fit everything you want in one namespace, which isn't pretty, but we found a way around it. There isn't an import keyword, and that means you have to fit everything so you cannot have two namespaces, one namespace on another library and just import it. It doesn't work like that. You have to redefine all the types on the same namespace. And there aren't, for example, so there is no dependencies. There are no foreign language. There are no functional languages or object-oriented modern features. It's very, very imperative, let's say. It's very definitional. And there is support for custom types or for external types, but that is only for Kotlin and Swift and not for all languages at the moment. So also the UniFFI allowed types. So as you can see, they're pretty similar, so it's easy to understand actually what is what. So these are the natively supported ones. As I said, if you want to have custom or external types, you can't, let's say, if you want all 4 languages. But I think that most of them are just used in everyday library, and if you want to create a type you can do hacks, and you can do some workarounds and find a way to do that. So to go about more technically, in UniFi, one very important central concept is lifting and lowering. So, and it's a passage of arguments between domains, because of course you have to bridge between Rust types and Kotlin types and Ruby types and so on. They are not defined all the same, and we have to find a very strict way of going back and forth with them. So let's imagine, for example, we are calling this function here, and we are passing 2 arguments. Those arguments are then lowered by the FFI layer here, in this, for example, this. And each of these struct is defined, so this FFI converted type is defined together with this. They are all boilerplates. Then lifted again for use in the target Rust function. The Rust function executes, Rust result from the Rust function returns. It is lowered for the FFI layer. It is lifted to the target language binding, and it is returned here. So it's a pretty nice mechanism, I think. This functionality is used for all data structures, and they are all the boilerplates are cloned for every structure. So there is a lot of everything is explicit, which is both it's hard to find stuff if you have a large library, but also it's very good because there is nothing hidden. There is no hidden magic, and it's easier to debug if you have problems. Honestly, we didn't have with that. It works very well. So also, for example, as you can see, this encode extended spending key, it uses the Kotlin standards, because in Rust, for example, you prefer to write in snake case, and in Kotlin you have camel case. So every language is then written with their own language standard in mind. And they have all, just a small detail, they have all an ID. So it's also kind of easier to search when you need to find a function very quickly. So some remarks about the above. You need to get used to it because it's not very standard, but after everything is said and done, it is quite pretty and it feels like it leaves a lot of control to the user. There are limitations on the language features we can use, so we have to adapt and think a bit differently. We cannot export the architecture. That means that it's very hard to keep the same structure in every language. It's almost impossible. So you have to be a bit flexible. At the moment, the 4 languages I mentioned, they are all included in the main library. But in the future, they will be everything external, so only the core library will be maintained. And I think it would be amazing to see this tool more used in the blockchain space because I think it's really helpful and it's more inclusive for a lot more developers. For example, data analysts use mostly Python and they're not programmers, so they use Python because it's easy. And if more libraries use this tool, there will be more, I think it will be much more accessible for a lot more communities. So the Rust libraries will be much more accessible for other communities. And as in the blockchain space, Rust is used a lot, they're addressing this to date mostly. Everything is still under heavy development, so it can only get better, of course, with time, and so on. So tooling, the third segment. In this section, I will tell more about what we implemented apart from code and apart from the libraries. So what are the procedures we implemented? What are the automatization tools that were used to arrive where we are? I have to anticipate, I'm very proud to say that we created also a CLI tool, which actually eases the life of a developer and with automatizing stuff in a very easy way. So we strive to use the development time to make the library not only what was envisioned in the original RFP, but also to improve the automatization of certain processes inside UniFFI itself. So even these tools can be used even without Libra Zcash, but for any other libraries we want to bridge. So we have some of the following CI procedures as generating bindings and shared libraries. You can publish documentation to their respective pages, to their respective ecosystems. You can generate package and you can publish package to each language registry just by executing the CLI and of course doing some configuration before. But it's everything very automatic and it really removes a lot of baggage, a lot of bureaucracy from the process. And of course, package generation, which is, of course, building and testing, it's also included. So it was very easy to just send it to the CI and let it do all the repetitive things. So we built the CLI in a way as to pack and publish the generate bindings automatically. The CLI provides a multi-stage build and packaging process that intends to help developers in debugging scenarios. It helps with the local bindings build, it helps with publishing, and it generates docs as well. So it's also, this is another point, so in the CI we don't use much GitHub Actions native functions. We use a lot of Rust functions, which we use to concentrate. So the Rust, the GitHub Actions, the CI that I show here, they use 95% of the directories executed here. They all come from the Rust code base. So they're very customizable and it's everything very controlled. So yeah, so everything looks cool, but so how can you try it out? So the first version of the library is maybe found already on GitHub. I didn't use QR codes because then I thought it would be much easier to just download the presentation and click on them. The Swift may be used with the through Xcode very easily. You just enter in the package manager and then just paste the URL. The Python library may be downloaded with pip. The Ruby may be installed easily as a gem. And Kotlin, as well as through Maven or Gradle, it's very easy, of course, to include in the dependency file and just use it in the development. So side projects, some features were experiments or additions that can give benefits to all other potential users of the library. So the inline docs generation was, in fact, we needed to make a hard fork of the UniFFI library. So we are still working on possibly merging with the upstream library and then have just one library, of course, because it's better to have it included. We tested also with Elixir bindings using Rustler. The UDL split management means that, as I said before, the UDL file, to use it, you need to have one big giant spec file. We didn't want that. So we included also a subroutine that actually uses all the UDL files we wrote, because everything is very compartmentalized. And before compiling, before going into UniFFI engine, all the UDL files we generated, they're merged into a single one, and they're sent to the compilation. Support for Apple Silicon, which was not originally included in the grant proposal, but we decided, of course, a good idea to include it. And a complete CLI to use in the tasks after development. So conclusion, UniFFI is quite powerful, but still has a lot of rough edges. So as I said before, it's a bit hard, but you can get used to it, I think, in a couple of weeks. UniFFI is a good place to start for multi-language SDKs. So I want to emphasize, is a good place to start. So it's of course, the performances are not great, but if you want to give access immediate to some more ecosystems, it's a good idea to use it. It is still evolving, so it's a rich field for contribution. I encourage people to read what is UniFFI and maybe to contribute a bit more so that it grows more easily. Libra's Zcash as well is still being expanded with other features. So future patches will be needed, and we hope that we'll be able to also work on it and to be included in the future decisional process. And one last thing. I think that UniFFI is about creating a more inclusive environment where we need one major language to write for most ecosystems. So, questions? Yes.
Thank you, Luca. Big applause to him. All right, we have 2 questions. The first one is there something you don't like about UniFFI or UniFFI?
Is there something I don't like? I think what I don't like is that it has support for basic things, but of course a lot of features are missing. So for example, concurrency is still a bit hard. So another thing I didn't mention, for example, is that, of course, everything is, so memory management is still a very, very, I think, sore point, and it needs much more work. Because, for example, when you use structs in Rust, you have to wrap them with arc, and that means that Rust delegates the memory management to something else. So it's for advanced development is very not suitable at the moment. Yeah.
Okay, thank you. And another question is, do you have advice to people wanting to use UniFFI to create bindings?
So, an advice. I think that, well, the first thing is that you start with from like a hello world example, and then you try to generate bindings for that. And there is a manual on UniFFI, so just search UniFFI manual on Google, and it will be very easy to find. And there, everything is step by step, and that helped us a lot. There are sections also on internals to understand how it works internally, as some of the things I explained, like lifting and lowering. And be very patient, because the tests are not that fast. Yes, another thing I don't like is the test, because when at some point when we were writing tests, I think each suite could take, before we optimize it a bit, each suite of tests, so for each language, it took like 30 minutes. So it's like 2 hours of testing. It's a bit too much.
All right. There are no more questions from the public, but I do have a question.
Yes.
Are there any features or things that were not in the original RFP that you would like to implement in the future?
Well, for example, we would like to include synchronization in the future, and that were not present. It's hard to say, because there are a few features that, for example, they were included in the original RFP, and we couldn't implement because they didn't exist in LibreOS Zcash. So, yeah, I think there are some things still that we would like to implement, and can't say now which ones, so I cannot name them. But yeah, there's some other stuff. Just I don't remember. There's some other stuff we wanted to do, but otherwise the grant would be like too large then, if we went to include also them.
All right. There are no more questions from the audience. I don't have any more questions. So thank you very much.
Thank you.
Luca.